So welcome back guys. In this module we will start with L3 routing. So we will discuss L3 routing, that is the routing that is done by the network layer of the TCP/IP stack. Note that in L3 routing only IP addresses is used to deliver the packet from the source router to the destination router. Note the word the destination router. That is, L3 routing is used to send the packet from source subnet router to destination subnet router. L3 routing is not used for routing a packet between host machines. L3 routing is used to route a packet from one L3 router to another L3 router, right? So L3 routing means routing a packet from one L3 router connected to the source subnet to L3 router connected to the destination subnet. So this is the clear difference between L3 routing and L2 routing. L2 routing is used to send the packet from source machine to destination machine, and both the machines are present in the same subnet. Whereas L3 routing is used to send the packet from source subnet L3 router to destination subnet L3 router. It will be more clear in the next diagram. So you can see in this diagram there are two subnets. Subnet, let us call this subnet as A, which is 11.1.1.0/24, and the subnet on the right hand side is 12.1.1.0/24. Let us call this as subnet B. Now for the subnet A, the gateway router is this router 1. Let's call it as router 1. And for the subnet B, the gateway router is router 2. Now let us say the machine B wants to communicate with machine F. Now both machine B and F are present in different subnets. So the first thing that will happen is that the machine B will send the packet to its gateway router, that is router 1. This will be done via L2 routing. Then router 1 will send the packet to the gateway router of subnet B, that is router 2. This will be accomplished by L3 routing. So note that L3 routing is used to route the packet from one L3 router to another L3 router. And this internet in between represents any number of L3 routers that is present on the internet. So internet could be big, there could be any number of L3 routers in between router 1 and router 2. Now once the packet reaches the router 2, in the third phase, the L2 routing again plays its role, and L2 routing will be responsible to deliver the packet from router 2, which is the gateway router of subnet B, to the machine F. So you can see that a complete journey of the packet from source machine B to destination machine F includes L2 routing followed by L3 routing followed by L2 routing, right? So I hope that which type of routing plays a role is clear now, right? So in this example, L2 routing is responsible to take the packet from the source machine B to the gateway router. L3 routing is responsible to take the packet from source gateway router to destination gateway router. And L2 routing again is responsible to take the packet from destination gateway router to destination machine. So this is how L2 routing followed by L3 routing followed by L2 routing is involved whenever two machines present in different subnets on the internet wants to communicate with each other. Now let us take an example of our own topology which contains 3 L3 routers. So remember we created this 3-node topology using virtual machines and virtual box. Now you can start all the 3 VMs in your virtual box and log into these VMs. This we have already done this exercise. Now, log into VM and try to ping 192.168.4.1. So from the machine VM, are you able to ping 192.168.4.1? The answer is yes. You should be able to ping it because you are trying to ping an IP address 192.168.4.1 which is present in subnet 1. What is subnet 1? Subnet 1 is 192.168.4.0/24. So from the machine VM, you are trying to ping an IP address 192.168.4.1 which is present in subnet 192.168.4.0/24. Now, machine VM from which you are trying to ping has an interface Ethernet 2 which is present in the subnet 1. It means that the machine VM and the IP address which you are trying to ping are present in the same subnet. It means it is pure L2 routing. That is, pinging an IP address 192.168.4.1 from the machine VM is the case of pure L2 routing because the machine VM and the IP address 192.168.4.1 are present in the same subnet, which is subnet 1. In other words, we say that machine VM and machine VM1 are present in the same local subnet. And what is that local subnet? That local subnet is 192.168.4.0/24. For the same reason, are you able to ping VM1? That is, are you able to ping the IP address 192.168.1.2, that is this IP address, from the machine VM1? For the same reason, you should be able to ping, right? And the reason is same as before. Now, are you able to ping from machine VM the IP address 192.168.1.2, that is this IP address, or IP address 192.168.1.1, that is this IP address? You should not be able to ping. Why you are not able to ping? Because you are trying to ping an IP address which is present in a different subnet. Now, what is subnet 2? The subnet 2 is 192.168.1.0/24. This subnet, that is the subnet 2, is a remote subnet with respect to virtual machine VM. Why it is a remote subnet? Now the definition of the remote subnet is here. A subnet S is said to be a remote subnet with respect to a given router A if none of the local interfaces of the router A has an IP address which is a member of subnet S. So in this example, let us say the remote subnet is subnet 2, which is 192.168.1.0, and the router A, which we are considering, is our virtual machine VM. Now, is there any interface of the virtual machine VM which has an IP address such that that IP address is a member of subnet 2? The machine VM has only one interface Ethernet 2, which has an IP address 192.168.4.2/24, and this IP address is not a member of subnet 2. It means that subnet 2 is a remote subnet for machine VM. Similarly, subnet 1 is a remote subnet for machine VM2. You should go by this definition. If you follow this definition, it will be clear to you that which subnet is a local subnet with respect to a given machine and which subnet is a remote subnet with respect to a given machine. You should be able to identify whether a given subnet is a remote subnet or a local subnet with respect to a given router or a given machine. Right? So going forward, directly connected peer interfaces can always be pinged because only ARP is required, because it is a case of pure L2 routing. And when it is a case of pure L2 routing, the moment you create the topology using VirtualBox. The ARP get resolved automatically by the operating system, and the directly connected peer interfaces or the directly connected IP addresses are always reachable. That is, you can always ping the directly connected interfaces. VM do not know how to reach a remote subnet. For example, in our example, the machine VM do not know how to reach a remote subnet 192.168.1.0/24, which is subnet 2. So here our machine VM doesn't know how to reach a remote subnet 2, and the machine VM2 doesn't know how to reach a remote subnet 1, right? But what about the machine VM1? Machine VM1, by going this definition, has an interface Ethernet 2, which is a member of subnet 2. That is, has an interface which has an IP address, and that IP address is a member of subnet 2. Similarly, machine VM1 has an interface Ethernet 2, which has an IP address 192.168.4.1, and this IP address is a member of subnet 1. It means for the machine VM1, subnet 2 and subnet 1 both are local subnets for machine VM1. We are going by this definition because machine VM1 has an interface which has an IP address, and that IP address is a member of subnet 2, as well as has an interface Ethernet 2, and that interface has an IP address 192.168.4.1, and this IP address is a member of subnet 1. It means that the virtual machine VM1 is local to subnet 2 as well as subnet 1, and it is for this reason that from machine VM1 you can ping 192.168.1.2, and you can also ping 192.168.4.2, because both the subnets are local subnets with respect to machine VM1. So I hope it is clear that what is remote subnet and what is local subnet. To ping any machine which is present in the local subnet with respect to a given machine, you can always ping that machine because only ARP is required or only L2 routing is required. But to ping any machine which is present in a remote subnet, you need to have a L3 routing table, which we have not yet configured. So that is the reason that without having L3 routing table entries, you cannot ping any machine present in the remote subnet. Now let us take another example here. If virtual machine VM need to send the data to VM4, so machine VM wants to send the data to VM4. VM do not know where to send the data packet. Whether VM doesn't have the intelligence that to reach the machine VM4 in the network, should it send the data packet to VM1 or should it send the data packet to VM3? It doesn't have this knowledge. And that is the reason where L3 routing table is required. L3 routing table gives the knowledge to the machine that in order to reach a certain destination in the network, what is the next hop machine it should send the data to. So we will going to discuss next how to configure the routing tables. So every machine in the network, actually every L3 router in the network need to have a routing table. So note that only L3 routers have routing tables. Your L2 switch, your bridge or your host machines do not have routing tables. Only L3 router have routing tables. So routing table is a property of L3 router and not L2 switch. So let us first understand what are L3 routes. That is, how does L3 route look like? What are the semantics of L3 routes? So the L3 route is an entry in the routing table of a router or a device which tells the router the next subnet to forward the packet to, so that packet eventually reaches the destination subnet. L3 router is made up of three entities. What are the three entities? What is the destination subnet? So this is actually the key of L3 routing table entry. So destination subnet, it means to reach a certain subnet, what is the next hop, IP address, and what is the local outgoing interface. So these are the three important fields which constitutes a routing table entry. The field 1 is called the destination subnet, in which the destination machine which you want to send the data to is present. So this is a destination subnet, and in order to reach this destination subnet, what is the next hop? IP address. And in order to reach this subnet D, what is the next hop? IP address. And in order to reach this next hop IP address, what is the local outgoing interface? So we will take an example of how actually the routing table entry looks like. So let us teach VM how to reach remote subnet 192.168.1.0/24, that is this subnet. So here we will going to install this routing table entry, and this routing table entry gives the intelligence to the virtual machine VM and teaches the virtual machine VM how to reach a subnet 2. Now let us discuss this routing table entry. So we will going to insert this routing table entry in the operating system of our virtual machine VM. So the command is up route add -net, then followed by destination subnet. So the destination subnet comprises of the IP address with subnet mask. So 192.168.1.0 is also represented as 192.168.1.0, and instead of /24 we need to specify here in the ABCD format, the net mask in the ABCD format. Then gateway IP is represented as follows, that the next hop IP address is 192.168.4.1, that is this IP address. It means for the virtual machine VM to reach a subnet 2, the next hop IP address is 192.168.4.1 and the outgoing interface is Ethernet 2. So we have discussed all the three fields of the routing table entry. The field 1 is this one, that is the destination subnet. The field 2 is the gateway IP address, and the field 3 is the local outgoing interface. So this is how the routing table entry looks like. We will going to install this routing table entry in our Linux virtual machine VM, and we will see that what is the effect of installing this routing table entry. So from this entry, the virtual machine VM knows that whenever it has to send the packet to remote machine, with the destination IP address 192.168.1 dot, and the last digit could be any digit, because any number between 1 to 254 will going to reside in subnet 2. Any IP address, if you in the last octet of the IP address, if you specify any number between 1 to 254, all those IP address will be a member of subnet 2. Then it has to send the packet out of interface Ethernet 2 towards peer interface whose IP address is 192.168.4.1. So this is the meaning of routing table entry. Now it's time for the demo. We will going to install the routing table entry in the virtual machine VM and teaches the virtual machine VM how to reach a subnet 2. And we will going to install routing table entry in virtual machine VM2 and teaches the machine VM2 how to reach a remote subnet 1. So there are three black windows. So this is the virtual machine VM, and this is the virtual machine VM1, and third window is virtual machine VM2. Now let us see the routing table entry. Okay, so I am on virtual machine VM. So we need to edit a file to statically or persistently configure the routing table entry in the routing table. So that file is sudo vim etc network interfaces. So I have already installed the entry. You just have to copy paste this line. So up route add -net, and what is the destination subnet you want to reach? The destination subnet is 192.168.1.0/24, and the next hop IP address is 192.168.4.1, and the outgoing interface is Ethernet 2. So this is the entry that I have installed in virtual machine VM. Similarly, let's see what is the routing table entry I have installed in virtual machine VM2. So sudo vim etc network interfaces. So here also I have added the corresponding routing table entry. You can see up route add -net, and what is the subnet? What is the destination subnet? 192.168.4.0/24, and the next hop IP address is 192.168.1.1, and the outgoing interface is Ethernet 3. So you can map these entries by looking at the diagram in a topology. So I have already installed these entries in these files. You just need to copy paste this line into your etc network and interfaces file and restart the virtual machine. You need to restart the virtual machine. Now let us see what are the entries I have installed in virtual machine VM1. So you can see that I have not installed any routing table entry in the virtual machine VM1, and I have already explained that for the virtual machine VM1, both the subnets, subnet 1 and subnet 2, are local subnet. So VM1 can reach VM2 and virtual machine VM using L2 routing only. So there is no need to install any L3 routing table entry in the virtual machine VM1. So that is the reason that the file for virtual machine VM1 is empty. Now let us try to ping. Now if you have installed the routing table entries as we have discussed, you should be able to ping the subnet 2 from virtual machine VM, and for that you can trigger the command. So from virtual machine VM you can ping 192.168.1.1. So if you get this kind of reply, it means the virtual machine VM1, because I pinged 192.168.1.1, so the virtual machine VM1 is responding to virtual machine VM. And if you ping 192.168.1.2, it means the virtual machine VM2 is also responding back to virtual machine VM. You can also do the similar exercise on virtual machine VM2. You can ping any IP address which belongs to the subnet 1, let's say we should ping, let's say we try to ping 192.168.4.2, and virtual machine VM is also reachable from virtual machine VM2. So this is happening because we have installed the routing table entries. Without routing table entries, it would not be possible for us to ping virtual machine VM2 from virtual machine VM, and vice versa. So the conclusion is that LT routing entries are required to reach any non-local subnet. Again, as long as a remote subnet is reachable, you can ping any machine, any host machine present in that remote subnet. So guys, you can also check and confirm the routing table entries in the routing table. So guys, you can also confirm the routing table entries in the routing table using route -n command. For example, I am on virtual machine VM, and if you just do route -n, it will show the contents of the routing table. Remember, this routing table is stored in your operating system, in your Linux operating system. So you can see the entry which we have installed in our routing table entry. And remember that because we have hard coded this entry in the etc network interfaces file, this entry will going to be there and it will be persistent across reboots. So this entry will be permanently present in your routing table. Similarly, on virtual machine VM2, you can do route -n, and it will show you the routing table entry which we have installed on virtual machine VM2, and this routing table entry is also persistent.